Hello guys, in this video we are going to discuss the solution of the problem deletion and reverse in circular linked list. So let us look at the problem statement. The problem statement says given a circular linked list, the task is to delete the given node, key in the circular linked list and reverse the linked list. So for instance, if this is the circular linked list which is given to us and the key to be deleted is 8, then post deletion and reversing the circular linked list, the linked list or the resultant linked list will look something like this, and the head of this circular linked list is what we need to return. So that's about the problem statement, folks. Now let us discuss the solution of this problem. So let us first discuss the case of deletion in a circular linked list. So over here there are three cases which are possible. First case is when linked list contains just one node and that node needs to be deleted. The second case is head of the linked list needs to be deleted, and the third case is any other node of a circular linked list needs to be deleted. So let us discuss the pseudocode for each of these cases. So let us discuss first case where the linked list contains just one node and that node needs to be deleted. So let us say this is the node which is given to us and this is a circular linked list. We need to delete this node. So the resultant node after deletion will be a null pointer, and that is what we are going to return. So in this case, we just want to return none or null. So that's about the first case, folks. Now let us discuss the third case before discussing the second case. In the third case, we want to delete any node other than the head of the linked list. So let us discuss that case. So this is case 3 where we want to delete any node other than head of the linked list. So let us say this is the circular linked list which is given to us and we would like to delete this node. So in order to delete this node, all we have to do is we have to find out a previous node. So let us say this is the previous node. So we have to find out this node and we have to find out the node that needs to be deleted. So we also have to find out this node. Now once we have found out previous and PTR, all we have to do is we have to break this pointer and we have to form a new pointer, which is this. And the way we will be able to do this is essentially previous next is equals to PTR next. And folks, in this case, this was our head of the linked list. And since in this case, the head of the linked list is not getting changed or updated, because of which we are going to return head of the linked list. Now let us discuss the case where we want to delete the head of the linked list. So this is case 2 where we want to delete head of the linked list. So let us take the same example. So let us say this is the linked list which is given to us and we would like to delete this node which is the head of the linked list. So folks, this is also the head of the linked list. So folks, as we have discussed in case 3, in order to delete any node, all we have to do is we have to find out its previous node. So in this case, the previous node will be this node. And once we have previous node and PTR node with us, all we have to do is we just have to update previous next is equals to PTR next. So essentially, this link will be broken and a new link will be established, which will be previous next is equals to PTR next. And folks, there is just one minor detail over here. Since now the head has been deleted, so the head has to be moved forward. So now in this case, the head of the linked list is this, and this will be given by PTR of next. So all we have to do is we have to return PTR of next. And in this way, we will be able to delete a node in a circular linked list. So folks, that's the discussion regarding deleting a node in a circular linked list. Now let us discuss how we can reverse a circular linked list. We will be able to reverse a circular linked list in the same way we reverse a singly linked list, with just one minor modification, and let us discuss that. So let us take an example for that. So let us say this is the circular linked list which is given to us. So similar to singly linked list, we will have a previous pointer. Initially the value of previous is equals to null, Then we will have a PTR pointer, and this PTR is pointing towards the beginning of the linked list. So PTR is equals to head of the linked list. So let me represent this. So this is the PTR, and right now previous is equals to null. So in order to reverse the linked list, all we have to do is we have to break this pointer and we have to make it to point like this. So let us do that. And the way we will be able to do this is essentially First, we will preserve the next pointer. So next will be equals to PTR of next. After preserving this pointer, now we will manipulate the next pointer. So let us manipulate it. So PTR of next will be equals to previous. Previous is equals to PTR and PTR equals to next. So let me explain this. So let us say PTR is over here and we have manipulated this. So PTR next is equals to previous. So right now the next which was pointing in this way, that gets broken and right now it is pointing to null. And after that we have updated our previous and PTR. So essentially previous node comes over here. So this become our previous now, and PTR gets moved to the next element. So PTR will come over here. Again the same thing will happen. So PTR next, which is this pointer, will be broken, and this will be equals to previous. PTR next is equals to previous. So now this pointer will be established, and after that we are going to update our previous and PTR. So this becomes my previous and this becomes our PTR, and in this way we will be able to manipulate the next pointer of all the nodes. And folks, the minor modification which we do over here is, so after reversing the node will look something like this. The minor modification which we have to do over here is the last pointer, which will be this pointer. Now it should point to the beginning of the linked list. So it should point it over here. And in this way, we will be able to reverse the entire linked list. And folks, the way we will be able to do this is, essentially this is the head pointer and this will be our previous pointer, and all we have to do is head dot next is equals to previous, and now the updated head will be given by previous, because of which we just have to return previous. So that's the discussion of solution, folks. Now let us discuss the pseudocode of this problem. So first let us discuss the case of deletion. In this case we want to delete a key from the linked list. So let us discuss this. So the first case we want to find out is if not head, which simply means the linked list is an empty linked list, or head next equals to head, which simply means that there exists just one node in this linked list, and this node is what we want to delete, and head.data equals to key. If this is the case, then in such case all we have to do is we just have to return none, because after deletion the linked list will not contain any element, because of which we are returning none in this case. Otherwise, if this is not the case, then ptr1 equals to ptr2 equals to head. So we are going to take two pointers, ptr1 and ptr2. Initial value of these pointers is equals to head, and we are going to take one more pointer, which is previous pointer, which is equals to none. So recall from our discussion, in order to delete a node from a circular linked list, we need to know previous pointer and PTR pointer. So now the next thing is we would like to find out the PTR pointer and previous pointer. So for that what we are going to do is we are going to iterate on the linked list while PTR1 data is not equals to key and PTR1 next is not equals to head. So with this condition we are searching for the key, and the second condition is just to ensure that we do not end up in infinite loop. What do I mean by this is, let us say the key does not exist in the linked list. Then in such case we want to exit once we have iterated on all the elements of the linked list, and the way we will be able to find out whether we have iterated on all the elements is essentially by doing this ptr1.next is not equals to head. And in this while block all we have to do is we have to update our previous pointer. So previous is equals to ptr and ptr is equals to ptr of next. And in this way, we will be able to find out our previous and PTR pointer. Now, once we have found out our previous and PTR pointer, we want to delete it. Before deleting a node, we also have to check whether previous is not equals to none. So if not previous, and the reason why we are checking is, so let us understand that through an example. So let us say this is the linked list which is given to us, and this is the node which we want to delete. In this case, if you iterate on this loop, which is line number 5 to 7, you will realize that previous will not be updated because PTR, the first node itself, the condition will be satisfied and previous will not be updated. And this is the only case in which previous will not be updated. In such case, PTR will be over here, which is fine. But we also have to find out previous. And what will be the previous? Well, previous will be our last node. So in such case where previous is not equals to none, all we have to do is we have to find out the last node of the linked list. So let us find out the last node of the linked list. So if not previous, which simply means previous is equals to none, in such case all we have to do is we have to iterate on ptr2 while ptr2 next is not equals to head of the linked list, and all we have to do over here is ptr2 equals to ptr2 dot next. This is true, folks. And once we have done that, towards the end of this loop, towards the end of while loop, we just have to set previous is equals to ptr2. So after the end of this loop, ptr2 will be over here. So this will be our ptr2, and this is where previous has to be set. That is why previous is equals to ptr2. So now we have found out our previous and PTR, and once we have found out our previous and PTR, all we have to do is delete that linked list. And once we have found our PTR1, I'm sorry folks, this is PTR1, this is also PTR1, and this is also PTR1. And once we have found out our previous and PTR, all we have to do is delete that node. And the way we will be able to delete this is previous.next is equals to ptr1.next. And towards the end, we just have to return the head of the linked list. And the way we will be able to do this is if ptr1 is equals to head. So we are deleting the head of the linked list. In such case, all we have to do is we need to return ptr1.next. Otherwise, we just have to return head of the linked list. And in this way, we will be able to delete a node from the linked list. So that's the pseudocode for delete, folks. Now let us discuss the pseudocode of reversing a circular linked list. So let us say we want to reverse a linked list and head of the linked list is given to us. So for this, all we have to do is we first have to check whether it is an empty linked list or it is a linked list which contains just one element. In such case, we don't have to do anything. We just have to return head of the linked list. Otherwise, we will take a previous pointer, previous is equals to none, and we will take a PTR pointer, PTR is equals to head of the linked list. And then we will iterate on all the elements of the linked list. So while ptr.next is not equals to head. And folks, since this is a circular linked list, because of which we are doing this, otherwise in normal cases or in the case of singly linked list, we just do while ptr. After doing this, we first have to preserve the next pointer. So next is equals to ptr of next. And after preserving the next pointer, all we have to do is ptr next is equals to previous. And after manipulating the pointer, let us update our previous and ptr. So previous becomes equals to ptr and ptr equals to next. And in this way, folks, we will be able to manipulate the next pointer of all the nodes but the last node. And the reason why we were not able to manipulate the last node is because of this condition. So in order to manipulate the last node, all we have to do is we just have to repeat the same process, which is ptr, which is at the last node of the linked list. So ptr next will be equals to previous and previous will be equals to ptr. So in this way, we have reversed the last node of the linked list. After that, the last node of the linked list should point to the head of the linked list. So the last node is given by head. head.next should point to the beginning of the linked list, and the beginning of the linked list is pointed by previous. After doing this, all we have to do is we just have to return previous. So that's the discussion of pseudocode, folks. Now let us see how we have implemented this in Python and C++. So first, let us look at the Python implementation. Let us discuss the delete node case. Over here, we are checking whether the linked list is an empty linked list or it contains just one node. In such case, we are just returning none. Otherwise, we are taking two pointers, ptr1 and ptr2, and initial value is equals to head and previous is equals to none. Then we are finding the key that needs to be deleted, and at the same time we are trying to find out the previous node as well. So in this way, through this loop, we will be able to find out the previous and the node to be deleted. Folks, this is one case which I missed to discuss during pseudocode. This is the case where the key to be deleted is not found in the linked list. If that is the case, then the key is not there in the linked list, because of which nothing needs to be deleted and we can just return head of the linked list. Otherwise, we are checking the case where previous is equals to none. So if previous is equals to none, then in such case, previous should point to the last node. And that is what we are doing it through this loop. Once we have found out our previous and PTR pointer, in order to delete the PTR pointer, all we are doing is previous.next is equals to ptr1.next. And then we are checking whether we have deleted the head of the linked list. If we have deleted the head of the linked list, then new head has to be passed and the new head will be pointed by ptr1.next. Otherwise, we are returning the head of the linked list. So that's the Python implementation for delete node, folks. Now let us discuss reverse function. So for reverse, we are checking whether it's an empty linked list or this is a linked list which contains just one node. If either of these two conditions are satisfied, we are returning head. Otherwise, previous is equals to none and last is equals to head, and then we are iterating on the linked list and we are reversing the nodes. These two statement is to reverse the last node of the linked list, and then this condition is to ensure that the last node of the linked list points to the beginning of the linked list, and towards the end we are returning the head of the linked list. So that's the Python implementation, folks. Now let us submit our solution. So our Python solution got accepted. Now let us look at the C++ implementation. So the C++ implementation is also the same, folks. In delete node, we are checking whether it's an empty linked list or the list contains just one node. In such case, we are returning null. Otherwise, ptr1 and ptr2, which initial value is equals to head and previous is equals to null. Then we are finding out ptr and previous. If the key to be deleted is not there in the linked list, then we are returning head. Otherwise, we are checking whether previous is equals to none. If previous is equals to none, then previous has to be set to the last node, which is what we are setting it via this loop. And after that, we are deleting a node and then we are returning either head or ptr of next. So that's the delete node function, folks. Now let us discuss the reverse function. In reverse function, we are checking whether it's an empty linked list. In such case, we are returning head, or it is a linked list which contains just one node. In this case also, we are returning head of the linked list. Otherwise, previous and last, and we are reversing the linked list. Then with these two statements, we are reversing the last node, and with this statement, we are ensuring that the last node points to the beginning of the reversed linked list, and towards the end, we are returning the head of the reversed linked list. So that's the C++ implementation, folks. Now let us submit our solution. So our C++ solution also got accepted. That is all from this video, folks. In case if you have any question or comment regarding this video, please feel free to use the comment section and I'll try to address them. Thank you.